Good morning. Today we're going to be talking about squares, cubes, and their roots and equations that contain them and what you need to do to help yourself out. So what does it mean to square a number? I know you guys have discussed this before. If I take a number to the second power, this does not mean 5 times 2. It means 5 times 5. So that exponent is always going to tell me how many times I'm going to multiply it times itself. So 5 squared would be 25. And if I'm talking about a square, that means I'm going to be doing it 2 times. So -5, remember if it's inside the parentheses, that means I want to square exactly what is in the parentheses. So I'm going to do -5 times -5, and I will get positive 25 for that one. When the negative is not inside parentheses, this means I want to square the 5, and then I want the opposite of whatever that is. So I don't take this until the end. So that means I want the opposite of 5 times 5. Well, that would be the opposite of 25, which is -25. Now, as with anything in math, whatever I do, I need to be able to undo. And so to undo squaring a number, you do the square root. So when I look at the square root, if I see a number under this, it's called the radicand. It looks like a fancy division sign, so it's called a radicand. When I see a radicand, I need to make sure that I think to myself, what number multiplied by itself could get me here? Well, I know that 5 times 5 is 25, so the square root, in other words, where I started, what that base number is, was 5. So with this we have the exponent is the 2, the 5 is what we call the base, and then this would be the radicand or square root sign. This is telling me I want the opposite of the square root of 25. Well, the opposite of the square root of 25 would be -5. If I have the negative on the inside, we have something called the imaginary number. And what this means is it's like I have the square root, and if I were to break down 25, well, that is 5 times 5. But it's like I'm also multiplying times a -1. You can't take the square root of a negative number, because to multiply something to get a negative, I would have to do -5 times 5 in order to end up with a negative answer. So what we do is we say we have the square root of 25 is 5, and then we put the imaginary number, which is I. So that is how we deal with that. So numbers that give you a rational number when you take the square root, these are perfect squares. And they're not going to have decimals per se. They might give you a fraction, and then that would give you a decimal. You could turn it into a decimal, but not going to think about it as like some long repeating decimal that never ends. So perfect squares. Any number when I square it times what it gives me. So like if I had radical 9, I would get 3, because that's 3 squared. Radical 1 just gives me 1, because 1 times itself is 1. I might have something like the square root of 1/4, and I can do this because the square root of 1, I can think about this as the square root of 1 over the square root of 4, and that would give me 1/2. So it's anything that's going to give me a rational number when I finish. So our perfect squares, if you think 1 times 1, well, that's 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And then we've got 36, 49, 64, 81, 100, 121, 144, 169. Those are all really common ones that you'll see. You'll see 225, which is the square root of 15. So that's a really common one to see. I skipped 14 squared. I don't feel like you use 14 squared a lot. So it's just not one that I will include in there. So squaring is when you take it times itself 2 times total. So the number times itself, and then we're done. When I talk about cubes, I'm going to actually take it times itself 3 times. So the number times itself times itself. So 5 to the third power means 5 times 5 times 5. So 5 times 5 is 25. 25 times 5 is 125. Think about if I had 3/4. Same thing with this one as we had up above. We're going to have negative 5 times negative 5 times negative 5. I have 3 negatives, so I'm going to get negative. So negative 125. Remember this one, I'm going to want the opposite of just that number times itself 3 times. So I want the opposite of 125, which is negative 125. In this case, it doesn't obviously make a huge difference, but I want you to see that that is how that occurs. If I take the cube root, it's got that radicand. I'm going to zoom in there a little bit. But you notice there's a little 3 there. So that little tiny 3 tells me I don't just want the square root, I want the cube root. So I have to think about what times itself 3 times. And that would be 5. And we can see that from our work above. Now this is like above as well, where we had, I want the opposite. So I'm going to take care of this first. And that is 5, and then the opposite of that is negative 5. Now we were doing the square when we had that negative in there. We were like, oh, we can't do that because we get, we get the imaginary number I. With this we don't do that because if you noticed up here when I do negative 5 times negative 5 times negative 5, that gave me negative 125. So I can actually pull this out because I can multiply times itself 3 times and still get that. So numbers that give you a rational number when you take the cube root are called perfect cubes. And so examples of those, like what we saw above, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 becomes 27. So you can see these grow a lot more quickly than the others. Alrighty, so the next one would be 4 times 4 times 4, which would be 64. 5 times 5 times 5, 6 times 6 times 6. So these are ones that you just kind of want to get used to seeing. So when you're working, you'll be like, oh, I know that one, I know that one. And you won't use these probably as much in that, but you'll use these a ton. And I'm going to be doing some little games at the beginning of class to help you kind of remember those. So if I see these friends in equations, I just have to remember like, oh, I need to undo that. So if I'm solving using the reverse of PEMDAS, aka SADMAP, right? Which step do square roots, cube roots, and which step do they fit into? They're going to be the very last step here. Almost the very last step. I am going to show you what to do with that one here in just a second, because you're going to be like, wait a minute, that doesn't follow it. You will always have 2 solutions when you take a square root, and I'm going to show you that as well. Alrighty, so on this one right here, I'm going to draw my line down. I'm adding 5, so I'm going to subtract 5. I have my x squared left, and then I have 36. So I'm like, how do I find the square root? I'm going to toss the square root around it. Well, the square root of that means that's x times x. So the square root of x squared is just x, because remember, x squared equals x times x. So that's how I'm able to get that. When I do the square root of 36, well, 6 times 6 equals that. Now it could be both positive 6s or both negative 6s. So we think of it as it could be positive or negative 6. And so what that means is it could be 6 or it could be negative 6. Negative 6 times negative 6 is indeed positive 36. So that's why I need to include that as a possible answer and why I have 2 answers when I do the square root of something. On this one over here, I drop my line down. I'm going to add 7. And I have the square root of x is equal to 2. Well, if I want to undo the square root, I'm going to do its inverse operation. I'm going to square it. which means I'm going to square that as well. When I square that, the square root times the square root is just going to give me it by itself. And then 2 squared is 4. And the reason that works, say I had the square root of 9. Well, if I had the square root of 9, if I were to square that, well, that is equal to the square root of 9 times the square root of 9. Well, the square root of 9 is 3, and 3, which gives me 9. So that's why when I square this up here, I get just the x. It just comes out, because here I would get just the 9 coming out. This one right here, I'm going to do something a little different. I am doing the cubing of this. I'm cubing it. So I'm going to go ahead and start and make my first step the cube root. And part of the reason I'm doing that first is I recognize that 216 is a perfect cube. And so this is 1, 2, 3, 4, 5, 6. So I know that's going to give me 6, and then that will just give me x plus 2 over here. And then I subtract 2, and x equals 4. So this is just the beginning here. We'll do some more practice with that. And let me know if you have any questions on that, but these notes are here to help you if you need them.